In this video, I'll explain to you the formula for the sample standard deviation, and then we'll also work through an example of how you would work on it by hand if you were to use a spreadsheet. I'll also show you the formulas for the spreadsheet. So first of all, I've taken a snapshot of our textbook, page 135, and this is explaining the sample standard deviation formula. So it's a formula that has a number of steps to it, and the big overall goal is to describe with your data set how far is each point from the mean on average. So some data points are going to be close to the mean, some will be far, and so we're trying to come up with this way to measure on average how far away are all the points from that kind of middle mean value. So if I were to break down this formula, I'm going to go straight towards the middle, and that is where we start all of our calculations. So I'm going to go to the numerator where we have a parenthesis, x1 minus x bar quantity squared. What that means is x1, take the first data point, that's what the 1 means, subtract from it x bar. X bar is your sample mean. Now, once you do that subtraction, you see the parentheses, it says to square it. So what we've done here is taken the first data point, figured out how far it is from the mean, and then we're going to get a subtraction, a difference, and then we're going to square that answer. So the squaring gets rid of any negative signs that might happen. Sometimes the number is bigger than the mean, sometimes the data point is smaller than the mean. We don't really care which way it is. We want to know how far is it from the mean and then square it to get a positive answer. So then you see the plus sign. Now we're going to repeat with the second data point. So x2 stands for the second data point. So second data value minus the mean, so how far are those apart, square that answer, gets rid of any negative signs. It also exaggerates that difference. So if there's a little difference, squaring a little number won't be very big. But if there's a really big difference, like an outlier, then you're going to get a very large little piece of this whole process. And then we keep on going through the third data point, the fourth, the fifth, the sixth, all the way through the nth data point. So n is your sample size. So go to the largest number in your sample, subtract the mean, get that answer, square it. And then when you have all of those little squared differences, we add them all up, and then we're going to average them. But we don't really average by the number in our sample. We're going to average by n minus 1, so 1 less than our sample size. And what this does is gets us a better estimate of the sample standard deviation. So if we divided by n, that would be like a population standard deviation. But when we divide by n minus 1, it's a sample standard deviation that we're computing. So samples are always a little bit wrong, so to kind of adjust for that wrongness, if you will, we're going to divide by n minus 1. And then to kind of undo all of that squaring that we did earlier on, we're going to square root that big giant answer. And once we take that square root, that answer is your S, your sample standard deviation. So I'm going to do this calculation with 2 data sets and just kind of give you a comparison to give you a sense of what the standard deviation actually means. So first, I have 2 data sets. How many pets do you own? And then how many teeth do you have? This was a sample that I'd taken from my classes, and these are actual responses from students. They may or may not have lied, so I don't know. Let's work with how many pets do you own. So I'm going to copy the data, just highlight it, Command C, copy it, and paste it over here in my data. And I need to come up with the mean of my data set. So how far are 2, 1, 4, 4, 2, 6, 3, 1, 2, and 7 from the average? So I'll go back over here and say equals average, and then open a parenthesis, highlight my numbers, close my parenthesis, push enter, and I have my average. Now, I just noticed that Google Sheets is saying, hey, we think that you want to compute another number, and they suggest an autofill. I don't want to do that right now, so I'm just going to X out on that. All right, there's my mean. If I add up all these numbers and divide by, how many data points do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, conveniently 10 numbers. The average is 3.2. All right, now we need that 3.2 to complete our second column of our calculation, x minus mean. So that means we're going to take the data point. So I'll say equals, to start a formula, 2 minus 3.2, push enter, and get an answer. And I see that Google wants to try to autofill all this calculations, and I'm going to say yes. Yeah, that looks good. You can also do it yourself. You can literally type in equals 1 minus 3.2, enter, and then to the next spot, equals 4. All right, so this is the x minus the mean. It's the data point minus the mean. 2 is 1.2 units below the average, which is 3.2. 1 is 2.2 units below the average. So that's what the negative says. It says to the left, below. Whereas 4, someone with 4 pets, their number of pets is 0.8 pets above the average. So there's a positive answer. Now let's go through and square each of these differences. So I'll type in an equals, click on my number, and then raise that number to the second power. So the caret symbol, which is above the 6, and then a 2, push enter, and I'm going to let Google autofill my numbers here. So when a number was really close to the mean, like 4, it was 0.8 units from the mean. When I squared that difference, it gave me actually a smaller number, and it's smaller showing that the data point was originally closer to the mean. Whereas 7, it is pretty far from the mean, 3.8 units. So its squared difference is going to be really large. It's been exaggerated by that squaring. It's giving me 14.44 for an answer. Okay, so our process, subtract the mean, square that answer. I've worked with this numerator, almost fully done. We just need to add up our numbers. So I'm going to say equals sum, start a parenthesis, and I'm going to highlight all of those squared differences. Close my parenthesis, and close my parenthesis, push enter. There's my answer, 37.6. So 37.6 represents all this stuff that would be on the numerator underneath the square root sign. So this sigma here, sum of stuff, that represents 37.6 with this data set. Now I'm going to divide my answer by n minus 1. So the sum of squared numbers, 37.6, divided by, let's see, we had 10 numbers minus 1, so divide by 9. Get an answer. So now we have computed this fractional part underneath the square root, and the last step is to take the square root. So I'll start with an equal sign, SQRT, start a parenthesis. I'm taking the square root of that last answer, close parenthesis, push enter, and so my standard deviation is just a little over 2. You might say that on average, the people own just over, so you might say on average that people own pets just a little over 2 units away on average from the mean of 3.2. So if you have that number 3.2, you can kind of get a ballpark of, okay, subtract 2 and add 2, so that's what, 1.2 up to about 5.2, and that's kind of a good range of where you'd find a lot of people and how many pets that they own. Now, if I repeat this, I'm going to compare a standard deviation for a different data set. How many teeth do you have? So let's see, let's take the standard deviation and type it back in here, 2.04, just for reference. Now I'm going to take my teeth data, copy. I'm going to just paste it right over here. I do need to make one more change though, because I need to come up with an average. So compute the average of the teeth data set. And do not autofill. So the average was 29.7. So I'm going to go back over here to my formula, and instead of subtracting 3.2, I'm going to put in 29.7 and then fill that column. So I just drag the formula down. So now here we can see that there's a lot of repeating numbers because there are a lot of people who have 28 teeth exactly. So I'm going to see the x minus the mean of an answer of negative 1.7 quite a lot, and anyone who's varying will have a slightly different difference. Then my formula was squaring the previous answer. So there's my squared deviations. Here's my sum of those squared deviations. And then I'm going to divide that sum by n minus 1. So same sample size, so we're still dividing by n. And then here we are, we're dividing, or taking the square root of that last sum. So we have 1.88. So our standard deviation is, let's say, 1.89. So I was actually expecting to see this standard deviation to be a whole lot smaller, but it is smaller than the last data set. It means that there's a pretty tight collection of numbers here in our data. There's not a whole lot of variance. There's more variation in the data for the pets than there is for the number of teeth that people have, just by a little bit. And I bet if we took a different data set that had much larger numbers, where we'd expect a lot more variety, then our standard deviation for either one of these might be a whole lot larger. So I hope that helps explain what the standard deviation formula means and how to work through it by hand in Google Sheets.